we're going to go ahead and play you a little video of how you use two components to make yourself some mobile RAS power. To power our RasPi through the GPIO power pins, we're going to need a few parts and tools. I'm using a variable voltage regulator and an LC line filter from Ready to Fly quads. Purchased for less than $4 total, these pieces will allow me to supply 5 volts of clean power to the RasPi. This is very important since we're going to be bypassing the fuse, regulator, and line conditioner built into the USB port of the Pi. I also purchased a pack of breadboard jumpers for about 99 cents, a female JST connector, and heat shrink tubing that can fit the regulator and line filter. Tool-wise, you'll need a multimeter, wire snips and strips, a soldering kit, a small Phillips screwdriver, and if you've got it, a hot glue gun. Start by snipping about an inch of wire from the JST connector. You'll be using this length to link the regulator to the filter. Strip and tin your wires, then solder the JST connector to the in pads of the regulator, making sure to line up the red wire with positive and the black wire with negative. Now, using the wires that you cut from the JST connector, connect the out pads from the regulator to the in pads of the line filter, once again making sure that red goes to positive and black to negative. Now we need to test our solder joints and set the regulator to 5 volts, the voltage that we need for our RasPi. Connect a power supply to your JST connector and attach your multimeter to the out pads of the filter. I'm using a variable power supply, but you can use any power source that can output between 5 and 19 volts. The multimeter should now register voltage. We haven't yet set the potentiometer on the regulator, so the multimeter should show you a voltage that is close to the input voltage. Using a small Phillips screwdriver, turn the potentiometer on the regulator until the multimeter reads 5 volts. Once set, that regulator should keep the output voltage within 0.05 volts of the desired output, as long as the input voltage is between 5 and 19 volts. With your voltage set, disconnect power and drop a small dollop of hot glue on the potentiometer to ensure that vibrations don't change the voltage output. Remember that we're bypassing all the built-in power regulation and conditioning on the Pi, so we need to regulate the power as much as possible with our harness. Pulling a black and red wire from our breadboard jumper pack, cut off the pin ends of each wire, then strip and tin. Solder them to the voltage out pads on the line filter, black to negative, red to positive. With your wires soldered, it's time to shrink wrap the regulator and line filter to protect them from shorting. The shrink doesn't need to be tight, just snug enough not to pull free during use. We're now ready to connect our completed power harness to the RasPi. Be sure to connect to the 5-volt pins and check your polarity. Any mistake here will kill your RasPi. On the RasPi 2B, look at the board with the USB and Ethernet ports pointing downwards. The power pins are the first 3 on the top right of the GPIO header. The first and second pins are 5-volt positive, while the third pin down is ground. Connect your power harness to the pins, black to the third pin down, red to the first or second pin down. Once again, double check before applying power, all of your wires, all of the pins, all the black and the red, because nobody likes a burned Pi. Once you're satisfied that it's right, connect power and you should see the RasPi light up. If so, congratulations, you now have a harness that can safely power your Pi through the GPIO header.
Burnt Pi. You couldn't resist.
I just couldn't. I had to put in some pun, something punny. I will say, because we're running this off of a battery, we probably could get away with just using a regulator, because that's going to provide pretty constant voltage. This is going to be able to provide pretty constant voltage, clean voltage off of a battery. The reason why I wanted to put a line filter in there is because I wanted hybrid power options. If I use a 5-volt AC to DC adapter, there will be all sorts of noise that gets injected into the line. The LC line filter uses an inductor and a capacitor to sort of even that out. It's actually a really inexpensive way. This is $3. It's an inexpensive way to make sure that you get clean power into the Pi. And again, because we're going through the GPIO header instead of the USB port, it means that we're bypassing all of the power protection that's built into this.
Right.
This actually has a small capacitor and a small inductor so that if I get dirty power in, it's not going to kill the Pi. If I put dirty Pi into the GPIO, I will blow this up.
You said dirty Pi into the GPIO.